All right, so now we're going to look at the periodic table, and where did this number of 40.08 grams is 1 mole of calcium comes from? It comes from the atomic mass. So I'm going to write the conversion factor from this. 40.08 grams of Ca, 1 mole is 1 mole of Ca. Or I could write the inverse of it. 1 mole of Ca is 40.08 grams of Ca. So I could write either of those as my conversion factor for it. So it says use that ratio to determine how many moles would be in 104 grams of Ca. So this is where my starting point is the information given. So 104 grams of Ca. You can use the train track method, I call it, or like the conversion factor. Train track method, I'm going to put this over 1. And so now these are multiplying. So since I'm multiplying, grams of Ca has to go on the bottom to cancel with grams of Ca on top. Moles of Ca has to go on the top here. So that tells me I'm going to use this conversion factor here because that has mole of Ca on top. So 1 goes with mole of Ca, 40.08 goes with grams of Ca. So this is the exact opposite of the ratio process because this is a multiplying, and when you're multiplying, the units have to cancel out. When you multiply and divide by something, it cancels out. So these grams of Ca cancel with grams of Ca. You're left with moles of Ca, and in the end, you're going to get 2.59 moles of Ca. Okay, so the unit, the 1 mole, 1 always sticks with the word moles in there. Let's go ahead and try another one. So in this next one, it says I have 104 moles of Ca. So I'm going to do this one just kind of as like multiplying with ratios. But I'm going to go back here, and this is my ratio here. Since it's moles of Ca here, I'm going to put moles of Ca on the bottom here, grams of Ca on the top. I'm going to use this ratio up here. 1 goes with moles of Ca. 40.08 goes with grams of Ca. Moles of Ca cancel out. When I multiply 104 times 40.08, I get 4168. The unit I'm left with up here is grams of Ca, and the question was asking how many grams. So that's how I'm going to solve that one. For my next one here, and my information in the problem is like my starting point. So when we did it some of the other ways, our starting point was our ratio. For this one, my starting point really is my problem. So my problem is 0.104 grams of Ca. So now I make my ratio. Grams of Ca on top, so it has to be grams of Ca on the bottom. That tells me I'm going to end up using this one here and moles of Ca here. And again, I should go back and talk to, this is my moles of Ca, grams of Ca. And this is my given from this ratio up here. So this would be 1. And this would be 40.08. So here, I'm going to multiply 0.104 times 1, and I divide by 40.08, and I get 0.00259 grams. I'm sorry, not grams. Grams cancels out. Moles of Ca. So the last one on here then is, it says I'm going to, this information given, 0.45 moles of Ca, put it over 1, or again, I could use my train tracks here, okay? So that tells me then moles of Ca has to go on the bottom, grams of Ca has to go on top. So I'm going to come up here and look. That's going to be this one here. 40.08 goes with grams, 1 goes with moles. Moles of Ca cancel, leaves me with grams of Ca. So when I take 0.45 times 40.08, I get 18.04 grams of Ca. So that's how I go about solving these problems using a conversion factor or factor label method.